This is year 14, unit 5 capacitor test, and the first question was a question from January 1988 physics 1, and it was question 8. So this is it blown up a little bit bigger, and you can see there it says calculate the maximum energy stored in the 3 microfarad capacitor in the circuit above. Okay, so first of all it says with the switch closed. So if the switch is closed there, you can see then that there's a short circuit around this capacitor. So all you have in your circuit is your 3 microfarad capacitor. So it's just a matter of using your equation. And given that you know that there's going to be 6 volts across your capacitor, because this capacitor here is out of the equation altogether, because all the current is passing around this way, around the circuit, short circuiting the 2 microfarads, then all you have to do is use your equation, which has got C is equal to 3 microfarads and V is equal to 6 volts. And so the equation is just E is equal to half CV squared, and that's equal to a half times 3 microfarads times 6 squared, which is 36, and that gives you an answer of 54, and I haven't changed the microfarad, so that's in microjoules. So the answer is 54 microjoules. Okay, the second part of the question then asks you to calculate it with the switch open. So that means that this part of the circuit is no longer in the circuit at all, and you've got your 2 capacitors here, they're in series, and that means that they're sharing the 6 volts. Now if you recall, it's a larger capacitor which gets a smaller amount of voltage, and so therefore we have to do a calculation to calculate how much voltage is across our 3 microfarad capacitor. Or what we can do is we can work out how much charge is there and use a half Q squared over C, which is a different arrangement of the energy equation. So it's up to you which way you do this. We'll maybe do it both ways so that you can see. So if I'll just show you here. I'll just draw a line down here. So depending on what way you did it, you may want to check this. And we'll do it first of all using calculating the total charge. So the first thing that we need to know is total capacitance. The 2 resistors are in series, and therefore we have to do product over the sum. 3 times 2 over 3 plus 2, it's all microfarads, and that gives you 6 over 5, and that's microfarads. So if I write down to calculate the total charge, and whatever the charge, if you remember in a series circuit, you've got the same amount of current flowing through a series circuit, and therefore every part of the circuit has got the same amount of charge. So if we calculate the total charge in the circuit, that's the same as the charge across each part. So the total charge here, QT, is equal to CV, that's just your C is equal to Q over V equation rearranged, and that's equal to 6 over 5 microfarads multiplied by 6, and that gives you a total of 7.2 microcoulombs. Right, so the last thing we have to do is work out what the energy is, and I'm just going to write down E is equal to a half QV, but V we know is equal to, write that down, V is equal to Q over C, so that's equal to half Q times Q over C, and that's a half Q squared over C, and so that gives you a half. Our energy calculation then is equal to a half times total Q is 7.2 microcoulombs squared, and that's divided by the capacitance, which is 6 over 5 microfarads, and that answer comes out as 8.64 microjoules. This is the second method of doing this question. So you know that in this circuit here, that if this is a series circuit with 2 capacitors, then each capacitor shares the amount of voltage, the 6 volts there. But it's actually the 3 microfarad capacitor which gets less voltage. And if I just write down C is equal to Q over V there, you might understand that a wee bit better. Obviously, if the answer there is 3, but the charge in each one of these is the same, then you must be dividing by a smaller answer, or smaller voltage here to get an answer of 3, and a bigger voltage here to get an answer of 2. Okay, so we're looking for smaller voltage. So if we just, down here, if we just look at the ratio of the capacitors is 3:2. And you have 6 volts, so obviously there's 3/5 and 2/5. So we're looking for the 2/5. So 2/5 of 6 volts is what the 3 microfarad capacitor gets, and that's equal to 2.4 volts, if that makes sense to you. And then all you have to do is E is equal to half CV squared, and that's equal to a half times C is 3 microfarads, and V is 2.4, and that's squared. And that gives you an answer of 8.64 microjoules, as we expected. Okay, the next question is a question 8 it came from June 2000. And you can see here the graph shows a graph of charge against voltage for a capacitor. What quantity is represented by the slope of the graph? So if you have a slope, then you're dividing charge by voltage. So if we write down Q over V, then that's obviously capacitance. So the answer there is capacitance. And then what quantity is represented by the shaded area? So you have to be multiplying Q by V. And if you're getting an area, and if you're multiplying Q by V and you're getting an area there, we know energy is a half QV. And that's obviously true that either this triangle or the triangle underneath is going to be a half QV because it's a triangle shape and that area is an area of a triangle. So the answer there for the shaded area is energy. The next part of the question, we've lost a wee bit at the side here when I made this a little bit bigger, but an electronic camera flash gun contains a capacitor of 100 microfarads which is charged to a voltage of 250 volts, so that the energy stored is 3.1 joules. So I think in your test everyone got this more or less right. So that's just E is equal to half CV squared, and that's equal to half times 100 microfarads multiplied by 250 squared, and that comes out at 3.125 joules, which when you round that up to two significant figures is 3.1. The next part of the question, the capacitor is charged by an electronic circuit which is powered by a 1.5 volt cell. The current drawn from the cell is 0.2 amps. Calculate the power from the cell, and then a second part, from this, the minimum time for the cell to recharge the capacitor. So the first part of the question, we're looking for a power. So P is equal to I times V, and you're told that the cell is 1.5 volts and the current is 0.2 amps. So it's 0.2 multiplied by 1.5, and that gives you an answer of 0.3 watts. There was a total of 3 marks going for this, so that would have been 1 mark for that answer. And then the second part of the question then asks you to calculate the amount of time to recharge the capacitor. So we now have a power. We also know that we have an energy, and we have the energy from the last part of the question, and the energy from the last part of the question is 3.125 joules. So energy is 3.125 joules, and power we have just there is 0.3 watts. And so we know energy is power, we know power is energy over time, and if you rearrange that, time then is going to be energy over power. And so that's going to give you 3.125 divided by 0.3, and that answer comes out as 10.4 seconds. So that's your answer, 10.4 seconds.